All right, let's learn about HCF and LCM using prime factorization. We'll be learning how to express numbers as a product of its prime factors, and we'll be looking into some examples of HCF and LCM. To begin with, HCF full form is highest common factor. In the previous lesson, we learned that factors are divisors that leave no remainder. So if you have a look at this example, HCF of 18 and 24, so factors of 18 are, we write this in pairs. First pair is 1 and 18. Second pair is 2 and 9. Then check if it is divisible by 3. 18 is divisible by 3, so 18 divided by 3, it goes 6 times. After 3 have 4. Is it divisible by 4? No. Is 18 divisible by 5? No. Is it divisible by 6? Yes. 6 is already there, so we can stop there. So these are the factors of 18. And factors of 24, similarly, are 1 and 24, 2 and 12. Is it divisible by 3? Yes. 3 8s are 24. Divisible by 4? Yes. 4 6 are 24. Is it divisible by 5? No. 6 is already there, so we can stop here. You can notice that there are some common factors here. Let's say 1 is a common factor of 18 and 24. 2 is another common factor. 3 is also a common factor. Okay. 6 is a common factor. So we just found out that there are 4 common factors of 18 and 24. We are trying to find the highest of common factors. Okay, out of these we can see that 6 is the highest among all of these common factors, so HCF is basically 6. But this is not how we calculate the HCF of 18 and 24. We basically do the prime factorization as we learned in the previous lesson. So 18 prime factorization can be 2, 9, 3, 1, like this. So 18 can be written as 2 times 3 square. 3 times 3 is 3 square. Okay. 24 is 2 again, 2 again, and 3 ones are 3. So it's basically 24 equal to 2 cubed times 3. After doing the prime factorization, we check what are the common prime factors. We can see that 2 is a common prime here between these two. 3 is another common prime between these two. Okay. So HCF is basically 2 should be there, 3 should also be there, but we take the lowest powers of the common factors. Between 2 and 2 cubed, this one has the lower power. 2 to the 1 is basically 2. So we have taken 2 here. Between 3 square and 3, 3 has the lower power. So we are taking 3 to the 1, which is 3. Now we will multiply them and we will get the same highest common factor as we did in the other method. Okay. So basically the highest common factor is the largest number that divides 2 or more numbers. Okay. Divides 2 or more numbers and leaves no remainder. So 6 is the highest common factor of 18 and 24. To the LCM, the full form of LCM is lowest common multiple. So this time it is not factors, this is multiples. So I've listed some multiples of 18. You can see that 18 ones are 18, 18 twos are 36, 3 times 18 is 54. This way I have listed up to 260 and the list goes on, because you can multiply 18 by any positive number, you'll get the next multiples of 18. Similarly, I have listed the multiples of 24 here up to 240 and the list goes on. All right. But we are trying to find the common multiples. Okay. So common multiples, we can see that 72 is a common multiple here. Okay. 144 is another common multiple. 216 is another common multiple. So out of these common multiples, we are trying to find the lowest of all the common multiples. Okay. So the lowest common multiple we can see is 72. All right. So LCM, we just found out 72. But as I said, we don't quite do the math like this. We do the prime factorization, then we find the LCM. So from the previous one, we have found out that 18 is basically 2 times 3 squared, okay? And 24 prime factorization gave us 2 cube and 3, okay? Now for LCM, we don't just take the common prime factors. We can take all the prime factors, be it common or uncommon. So we can see that 2 is a common factor here, 3 is a common factor here. If we had any other factors that are not common between them, we would take that as well in the LCM. This time we are taking the highest power of all the common factors. Okay, not the lower one. Lower one is for HCF, but for the LCM, lowest common multiple, we take the highest power of all the common multiples. So between 2 and 2 cubed, we can see that 2 cubed is the higher power value, so we'll take 2 cubed here. Okay, between 3 square and 3, this one has the higher power, so we'll take 3 square. Okay, then we will multiply them. Okay, 2 cube is basically 2 times 2 times 2, and 3 square is basically 3 times 3. If you multiply them, 2 2s are 4, 4 2s are 8, 3 is a 24, 24 3s are 72. We get the same LCM as we did in the other method. Okay, and another interesting thing here is you'll see that the HCF and LCM multiplied together of the two numbers will give you the product of the numbers. Okay, so we got the HCF as 6, LCM as 72, and the numbers were given as 18 and 24. When you multiply them, you'll see that product of the numbers is basically equal to the product of their LCM and HCF for two numbers. Okay, we generally need this when there are questions where product of the numbers is given, LCM is given, you're trying to find the HCF. So you'll simply divide the product of the numbers by the LCM to get the HCF, and similarly product of the numbers divided by HCF will give you the LCM. Okay, from this. Let's have a look at an example. It says find the HCF and LCM of 45, 60 and 75. Let's prime factorize them. 45 is divisible by 3. We know this is divisible by 3 because 4 plus 5 is 9. 9 is divisible by 3. Okay, it goes 3 1s are 3, 3 5s are 15. Then it goes 3 times again. 5 is a prime number. And then likewise we can do 60 is divisible by 2. Half of 60 is 30. 15, 5 and 1. And 75 is 7 plus 5 is 12 divisible by 3. Okay, we would take 3, 3 2s are 6, 3 5s are 15, 25 is divisible by 5. You can see that I'm doing this quickly. It needs a lot of practice to get to know that which number is divisible by what number. Okay, so as you practice more and more, you'll get to know that 45 is divisible by 3, 60 is even number divisible by 2. So this needs a lot of practice. Let's write 45 as 3 times 3, we get 3 square and 5. 60 can be written as 2 square, 3 and 5. 75 can be written as 3 and 5 square. After writing this, we can write HCF. Highest common factor is the all common prime factors in their lowest power. Okay, so common prime factors, we can see 3 is a common factor here with the lower power of 3 to the 1, so we will just take 3 here. 5 is another common factor here, common in all three of them. Okay, so in the lower power we get 5 to the 1, which is 5. This is the HCF, 3 5s are 15. Similarly, if you do the LCM, this time we'll take the common factors and uncommon, and we'll take the highest power of all of them. Okay, power of 3 here is 3 to the 2, so we'll just take 3 square. Highest power of 5 here is 5 square. Okay, and uncommon is 2 and highest power of 2 is given as 2 square. Okay, so let's just multiply them. 3 square is 3 times 3, 5 square is 5 times 5, and 2 square is 2 times 2. 3 threes are 9, 5 nines are 45, 45 twos are 90, 90 twos are 180, 180 times 5, we should get 900. So 900 is the lowest common multiple of 45, 60, and 75, all of them together. Okay. So to recapitulate, we have learned how to calculate HCF and LCM of given numbers. We take the common primes with their lowest powers for HCF, and we take all primes with their highest power for LCM. And we also learned that HCF and LCM multiplied together would give you the product of the numbers if two numbers are given. Okay, that's all. Thank you.